Hi, everyone. Welcome to another StarRocks community call. Today we have Rayees at RisingWave. RisingWave is a streaming database. And with that said, Rayees, take it away.
Thank you, Albert. Hello, StarRocks community. Happy to come here and share a little bit about RisingWave, the product. And first, a little bit of introduction from my side. My name is Rayees Pasha. I head the product team at RisingWave Labs. RisingWave Labs is a young company, a 3-year-old company, and our core product is RisingWave. And I'm going to present an overview of RisingWave as a product, how it's different in terms of wider market in the stream processing area. And then I'll end the presentation with how the integration and with StarRocks is built and what benefit StarRocks users can gain from leveraging stream processing in general and RisingWave in particular. So to kick things off, I have a quick, like I mentioned, the agenda is fairly simple. I want to start with the definition of RisingWave because a lot of people are new to the stream processing area. So it'd be good to introduce stream processing and how RisingWave fits in that picture. And then I want to emphasize how RisingWave is different from other solutions because there's some unique strengths that we bring to the market. And then finally, what is the value for StarRocks users, right, from adopting stream processing? So what is RisingWave? RisingWave is a distributed SQL streaming database. As the name suggests, we are a streaming database. It's an amalgamation of stream processing capabilities as well as the storage capabilities of a traditional database. So we combine both the capabilities so that if the user wants to process the data in motion as a stream, but they also want to store the results of that processing in a database so that users can query the data right away. So in a way, it's an emerging category because traditionally processing was seen as a separate area, and then storage of the processed data was seen as separate in the streaming world. So it's a new emerging category where in our case, how we're different is we're using SQL as the API to do all of this functionality. We are purpose built for stream processing. We are not a general purpose database that was used for something else that we co-opted for stream processing. So in a way, we are brand new. We open sourced our product April of 2022 under Apache 2 license. It's a liberal license. So we invite contributions and usage by community. And as a result of that, we are community driven, right? A lot of our focus is catering to community and addressing their needs from a roadmap perspective in terms of features and in terms of feedback. As you can see, some of the things that I want to highlight from a community perspective, we have fairly vibrant community. It's very engaged. We have about 6,000 GitHub stars on our public repo with a wide range of contributors of different capabilities, around 150 contributors who actively contribute their time and effort, and both in terms of the core code as well as testing and extensions to the product. And our primary communication channel for our community is a Slack community channel. We have about 1,500 Slack members where there's a lot of in-depth discussions happen about product and how they're using our product. And in terms of deployments, we are a Kubernetes-based product, so everything is containerized for RisingWave. And we track in terms of what the number of deployments are. We see about 150,000 deployments where all around the world, people are trying it either in dev, pre-prod, or prod. So this is we've seen a month-over-month constant growth in terms of deployment. So a healthy sign of how our product is performing in the market. So let me dive deeper into what RisingWave is, right? So what the core problem we're trying to solve. So from RisingWave core value proposition, we're trying to reduce the complexity of building a real-time application. In the market, when you have to build a real-time application, there's some unique needs. And if you are a big company, you can build a custom solution in terms of building the real-time application in terms of data acquisition, processing, and querying. So large companies have built their own custom solutions, and they have served well for them. But for those smaller companies to build it from scratch, it would take a lot. And for them, it's not just building the core system, but also how to how developers can use those systems. So both those problems required a new way of thinking, and that's where RisingWave came in. So we adopted SQL as an interface so that any developer who wants to build a real-time application doesn't have to learn a new API. They can just use their existing skill set from SQL and do it, right? And in the case of RisingWave, we kept it open in terms of what sort of data sources we support, right? We can consume data from any of the major message queues, for example, Kafka, Pulsar, Kinesis, Redpanda, any of those, and all of the major database vendors through CDC sources. So the basic idea is you build a real-time streaming application using pure SQL, and it's just a plug and play kind of model where you just create connectors to upstream data sources, and then you write SQL to process the data, and then it's ready for consumption by downstream applications through SQL. So that's kind of the basic idea. Now, how does this work, right? In a typical data pipeline, RisingWave is right in the middle, right? As I mentioned, the original data sources could be logs, applications, clicks, could be coming through any of the sources through message queues or databases. For RisingWave, every one of these sources is like a base table. Like in the traditional database sense, we treat each source unbounded stream as a table. And then once you ingest the data, you can join it through regular SQL syntax. You can filter through predicates. You can do aggregations. All of the transformations that you typically do with a traditional database, you can do it through RisingWave. Except here, instead of the data being stored in tables, it'll be like unbounded streams of data going through, right? And once you do the processing, we store the results right in the database. That's where the database part comes, right? The first generation systems, all they did was do the processing and then push the results to another data store from where users can query. In our case, we combined both as a full well-packaged solution. And once the results are stored in RisingWave database, you have two ways you can access. One is you can use any of the BI tools to query directly through SQL, or you build your own organic applications. And we also provide a web console to query the data. Or you can just push the results through a sync mechanism to a downline system. It could be a message queue, or it could be a database, could be a data warehouse. And for StarRocks users, this is probably the option they would say. If you're using StarRocks already as a data warehouse database, you take the full advantage of stream processing, and then just use your StarRocks instance as your application-facing data store. So that's kind of the high-level architecture. I want to switch gears a little bit to how we're different, right? What is different about RisingWave? What is the focus? Because if you think about database market, there are literally hundreds of database systems in the market, and it's only proliferating by the day. And so for RisingWave to come into market, what's unique that we're offering? The way to think about that is by what the workloads that run in databases, right? So, and typically one good way to look at it is through the latency of the workloads, right? If you can go from sub-second to hours and even days, right? And you categorize them typically from real time in the sub-second to batch, which could be taking hours and days. And if you think about the existing systems, there are a bunch of systems covering all these workload types for batch, for non-interactive, interactive, and real-time also, right? There's in-memory analytics system, the OLTP system that address real-time. Real-time is currently an overused word, but in a way, it is covered in some sense. So what's different about RisingWave is it's a new emerging category, right? You have a new type of data that has a short shelf life. We call that discrete event data. That could be coming from IoT devices, could be coming from financial transactions, could be coming from logs. As the data, stays, after it is generated, it loses value. So you need to act on the data right away, and you need a system that can get value discretely from that each event each event. So you need a system that can basically process the data while the data is in motion itself. You don't have the luxury of collecting the data in logs and periodically store it in some database, run some ETL, and then visualize. Because by the time the latency is so long that it loses its value. For example, if you're trying to track credit card fraud, or if you're trying to do maintenance on high value equipment with IoT, you do not have the luxury to say, I'll collect the log data, I'll leave it for a few minutes, and then I run some job every hour. By the time it's immaterial. You may still have some residual value in the data, but the main the core value is gone. And that's what we're trying to solve. In fact, stream processing as a category came aboard almost 10 years back, and the first generation systems addressed that problem. But the way they went through was very different. They were trying to be these unique systems which are built for some corner cases, for specific use case. What RisingWave is doing is trying to democratize that using SQL-based querying on that event data. So that's the core value we're trying to bring to the market. And what are our guiding principles, right? What is special about us that what we have adopted as the core North Star for our design? One is simplicity. Just to reemphasize again, we support fully featured SQL. So for StarRock users who are SQL aware, there's nothing new that you have to learn. You can just bring your skill set. You'll be able to start on day one if you're trying to do stream processing. The second for us principle is community, right? We are focused on developer needs. We use a liberal licensing, as I mentioned about Apache 2. So you don't have to think about you're not using a proprietary product or a product with a hybrid licensing model with open core kind of a model. This is pure open source Apache 2 license. So you can use it. You don't have to worry about having to worry about licensing later, right? Third is cost efficiency. That's another core thing that we have built into the product because it's easy to, the first generation system, as I mentioned, were built for these high-end systems, and they were really expensive to not only to buy, but also to manage. In our case, we adopted cloud native architecture so that we can lower the price performance. And this is by enabling elastic scalability so that you use minimal resources to run your streaming workloads. And the last thing is extensibility, right? Our system architecture is open. So we are not built into like one ecosystem. We're not Kafka based or Pulsar based or specific to a particular database. Like for example, we don't support only a subset of system. We're open. It's easy to build connectors to our system. And a proof of that is if you go to our documentation, you'll see both on source side, there are a ton of connectors that are growing by the day. And the same thing on the sync side, right? We have support for StarRocks. We have support for other database systems, Doris, which is similar to StarRocks and others. So in a way, our product is built to be extensible as an ecosystem. And then I want to talk a little bit about how we're different, the secret sauce, right? What makes us unique, right? Our value that we're bringing to the market is built based on these three core principles, right? Core features that I would call. One is our engine. As I mentioned, it is purpose built for stream processing. It's a native streaming design. By that, I mean, it's not like we took a traditional database or optimizer and then redid the optimizer just to address some issues. Everything is new, right? We started from scratch. Every line of code is new, and we've implemented in Rust for high performance and security. And we also adopted the best practices in terms of using better advanced algorithms for use of memory and tiered storage so that you can customize your deployment to keep cost and performance in mind. The second thing is the cloud native platform, right? At the infrastructure level, we support heterogeneous infrastructures. We're not bound into one particular architecture. And the way we do that is because of the fact that we have adopted Kubernetes and everything is containerized. So there's an abstraction layer. So you're not bound to a particular infrastructure layer. And we have separated data and compute, which allows us to independently scale them, right? If you have a lot of data and that grows over time, you can still use our system without breaking the bank, because you can still keep your compute, which is the more expensive part, footprint smaller. And you can also do ephemeral scaling. Whenever, if you have a workload that has a pattern that follows, like once a week you run or once a day you run, you can spin up cluster just for that small time period. And then all of the data is stored on S3 backup or an object store. So the cost of actually having that data in state is minimal, while the compute can come and go, right? And the third thing is, we don't, unlike other systems, we don't have a lot of dependencies like Zookeeper. And so if you're running RisingWave, you don't have to worry about 10 different things. It's a fully functional solution, so to speak, so that everything is deeply integrated. And then the last thing I think I mentioned about the extensibility, that again, the ecosystem wise, we are SQL based, we have a UDF interface. So if SQL is not sufficient for you, like if it's not descriptive enough, it's not, language is not rich enough for your use case, you can always extend it with a UDF library that we support, Python, Java. We have multiple language libraries, client libraries that you can use. And then obviously we plug into open standards and computing frameworks in terms of both ingestion as well as on the compute side. So those are the three key what I call the core features, like our secret sauce that we bring to the market. Now let me switch to the last thing that I want to talk about, which is why should you care, right? You as a StarRocks user, what is it that an integration with RisingWave would help, right? To do that, I want to spend a couple of minutes talking about the use cases of stream processing itself, because some of you may not be aware that when the word stream processing comes to mind, from a business logic and business use perspective, what does it mean from an end user, right? So this is a good way to depict what sort of use cases that we typically see. If you plot the latency, and when I talk about latency, it is the data latency, not the query latency, right? The distinction has to be made, because every database tries to be fast and tries to be real time. And there are some in-memory databases that are incredibly fast, that can return results in sub-second. But for them, the clock starts after the data is already in the database and processed and ready to serve. In the case of stream processing, it is when the data got generated in the original data source. So for us, the data latency is including the transit of data from source all the way to the system. So that, I think we should keep that in mind when we talk about latency. So with that, here are some use cases, right? If for the data latency, where if it is going from a millisecond to a few minutes, those are all stream processing use cases. And this could be, as I said, IoT related use cases, network monitoring use cases, for example, for security, for other reasons, recommendation. If you want to do dashboarding, it could be for financial or other reasons. Fraud detection is a strong use case. If you have a delivery app, which is basically if you have a mobile device and if you're communicating, how do you travel booking? This is a slightly higher latency one, I would say. And inventory tracking. This used to be a classic batch use case where you would run every day. Now with stream processing, you could run every few minutes to see how the inventory is, so that you can do intraday tracking. And these use cases are not just anecdotal. These are actual customers of ours who have used RisingWave for each of these use cases. Now we can't list them here because we have to have permission to list their names, but they are mostly, they have put RisingWave in production. So how does now those are the individual use cases from an industry perspective, right? What is the use case category, right? Because there is something common about all those use cases. And the way to think about it is there are two classes of use cases. One, what we call streaming ETL, and the second one is called streaming analytics. And this is important distinction because for StarRocks users, not all of those use cases apply, right? And even the use case categories, all of them don't apply. It's mostly the category A that would apply, and explain why. So streaming ETL is basically your traditional ETL that you would do, except in this case, instead of bringing in data in batch and running ETL process, here it's a continuous processing of ETL. So in a way, you have reduced the time it takes to transform data from some time-based window to a more like on-demand. Like, for example, with the streaming ETL, once you set up a workflow, it's not the user running a job that will perform the transformation. It is the arrival of data itself will trigger the transformation. And that's what the distinction is. In the case for users of StarRocks, others, they may already have a traditional ETL process before the data goes to StarRocks. Instead of using the traditional ETL, they could use streaming ETL, which allows them to have fresher data, newer insights available much sooner for StarRocks users. So that's one way you could use it. Now, streaming analytics is also a use case category that's very highly useful for us. It's more for real-time monitoring, dashboarding, in which case users would directly query from RisingWave. And obviously, that may not be a use case for StarRocks because you still want users to go through StarRocks. So in that sense, streaming ETL is a more applicable use case for you guys. So how does the integration look like? Now, this is a classic architectural diagram. So if you have, in a typical use case, you have source data coming in through operational databases, message queues. There are different ways. And this could be like multi-way. In our case, with RisingWave, you can literally have more than 10, 12 sources in disparate systems. Like you can have 3 Kafka topics, 2 databases. So you really can think of any combination of the data coming in. Now, with a traditional ETL tool, you would have to open each connection and have a complicated, complex data pipeline to process that. In the case of RisingWave, all of that becomes simple SQL. We have seen in some customer scenarios where literally thousands of lines of code gets translated to hundreds, even less than 100 lines of SQL. And once that transformation is done, we have a interface called materialized view, similar to the traditional materialized view. Once you set it up and encapsulate all that transformation logic in SQL, automatically as the new updates come in, the transformations happen and the results are stored. And then from that point onwards, the results of them, you can create a sync to StarRocks. And then automatically, based on that MV, you can create objects in StarRocks as tables, as views, however you want to create them. And then you can use your existing application if you have built an application on StarRocks, or if you're querying through a BI tool, that you can do directly. And this integration between Rising and StarRocks is, like I mentioned, it's called a sync in stream processing world. A sync is like a downstream target destination, right? And how we do that is we've built a deep integration already, and the details are posted here in our documentation. It's a simple SQL-based command. It's called create sync, and then there's parameters. And once you set it up, automatically, as processing happens, the results are automatically shipped from RisingWave to StarRocks users, a StarRocks system, and then they can leverage and query the data right away. So that's this integration and how the typical use cases would work. So let me pause here for a minute and see if there are any questions.
Yeah, so just like I have a question. So just like StarRocks, right? StarRocks has a community project, right? And then because we gave our we're a Linux Foundation project, right? We had to give our trademarks, and so we created a commercial company. We couldn't call ourselves StarRocks anymore. That commercial company is called Seller Data, and Seller Data sells as a managed solution, an enterprise solution for StarRocks. So what's the relationship on your end? So RisingWave is the community project. What's the equivalent on the enterprise side?
So we have a good question, great question, and we went through the same journey, right? Like StarRocks, we're also an open source project. The commercial entity is called RisingWave Labs. That's the name of the company, similar to Seller Data. We call ourselves RisingWave Labs, and the commercial product is called RisingWave Cloud. That's our SaaS offering, database service offering. That's available on AWS, GCP, and soon to be on Azure as well. And it's the same exact database, no change, nothing. We obviously build a service layer on top to deliver it as a service that includes some admin functionality, security, manageability, things that are required to deliver as a cloud service. But the core engine is exactly the same thing. So if a user wants to try the engine and self-deploy on their own through Docker, through Kubernetes, they can do it by all their means. But if they want to not have that overhead of managing infrastructure, deployment, support, all of that, then they can develop RisingWave Cloud.
Excellent. So do you have, I guess another question here is that, what are other use cases that you have that's that you might foresee with StarRocks and with RisingWave? So you mentioned a little bit before about some of the streaming use cases. What are other ones that you think that is applicable?
So streaming ETL is a strong use case, as I mentioned. Like it's a class of use case. So you can do transformations to push the data to StarRocks to query the data. Now, in terms of the actual use cases, it could be online serving, it could be recommendations, it could be even reporting, basic reporting that you do instead of generating those reports on a hourly basis or multiple times a day. You could do it like in real time, as opposed to a dashboard. That the way we do streaming analytics through directly using RisingWave as a data store, you could do the same thing with StarRocks. So in a way, if you think about it, if you have a dashboard that you're powering through StarRocks, the backend could be RisingWave supplying the data instead of you using your compute to do the transformations. Now, so there is a little bit of it's kind of a spectrum, right? From all the way from most recent data to maybe an hour, maybe a day, maybe a few days. But then if you really want to go a quarter, right, for example, that's beyond RisingWave. RisingWave is not meant for ad hoc querying on historical data. Although we do have some capability, but it's not the same as engine purpose built like StarRocks for ad hoc querying over historical data. So in a way, a good use case would be where you bring in the data from RisingWave, merge it or blend it with the historical data. And if you want to build a report that shows continuity, that would be a great showcase use case to showcase both systems, because you're not just using RisingWave as for some purpose, but you're actually blending both these the strengths of both these systems into one use case.
Great, thank you.
Any other questions, Albert?
I'm good for now. If there are any additional questions from the session, we'll take them now. All right, Rayees. All right. So I think we got some questions off of chat.
Yeah, I see a couple of questions. Can you guys hear me okay?
I can hear you just fine.
Yeah. So I see a couple of questions. The first one is, how is RisingWave different from Materialize? A great question. So Materialize has the same sort of the data model, and in terms of architecture they're different, but from an end user perspective they're Postgres compatible. They also claim to be they have a Materialize view interface for stream processing. The distinction comes from what's under the hood, in my opinion, because Materialize was built for a single server architecture, more like a SMP system, where if you could fit all the data in a single server, that's a great system to go with. And in fact, they started the journey as a compute-only engine, and then they added storage. In our case, with RisingWave, from the get-go, we were a distributed SQL engine, right? We adopted a shared nothing architecture, cloud-native separation of compute and storage. So all these attributes, which are kind of the infrastructure that is needed to build a system that can scale. And the proof is, like, most of some of our customers host terabytes of data, and in our case, all you need to do is add more compute, and you are up and running. So what I would say is mostly that they the architecture kind of differentiates us from them. And also one other thing is in terms of the positioning also. Even though we kind of started out on the same path, Materialize is going more towards operational data warehouse. That's how they're positioning themselves, more towards traditional data warehouse market, while we feel like our forte is still stream processing, right? We have the database functionality, obviously for serving, but if all you want to do is just stream processing, as I mentioned in the presentation for like especially StarRocks users, and you don't care about storing the data and serving from RisingWave, then you can use it as just a stream processing engine. So I hope that answers the question, Arif. Um, Let me go to the second question. That's also from Arif. Are there still scenarios, use cases where stream processors will be preferable over streaming database? Example, complex transformations that you can do with Spark Flink using languages like Scala or Python, but maybe a challenge because streaming database
Oh, it looks like we have a little bit of a network issue.
any and all use cases. Where I see there are use cases scenarios that where Flink can help
Oh,
is if you need to
Grace.
learn. Yeah,
Oh, we lost you for like 10 seconds, so maybe you wanna repeat the question really quick and then your answer again.
I'm sorry. Yeah. How about now? Can you hear me okay?
Yeah, yeah.
I think it might be a network issue. So I'll repeat the questions in the chat. So, are there any scenarios or use cases where stream processors will be preferable over streaming database? Example, complex transformation that you can do with Spark, Flink using languages like Scala or Python, but may be a challenge or not possible via RisingWave using SQL. So the question is basically, you know, RisingWave is a stream processor as well, but all they offer is SQL. Is SQL too limiting in certain use cases? The answer is short answer is yes. SQL and the way we address that is we have provided UDF library, so users if they have logic that they need to write in a non-SQL uh, express in non-SQL language, they can do it, but that only helps mitigate to a certain extent. So there may be use cases where users, especially advanced users, want to write low-level code, low-level API code. Unfortunately, RisingWave doesn't provide a low-level API. You have to go through SQL. So there are uh, that's that's a that's one of the ways I think I would answer. But there is help coming. If you are Python user and you still want to write Python code and use RisingWave as a backend, there is a project called Project IBIS. We collaborated with Voltron Data. That's a company that they are a pioneer in providing Python API. So they've been on a mission to unify batch and stream processing under the same API, Python-based API. And recently they announced support. We worked with them to provide RisingWave and Flink are the two backend engines they support. So if you are Python developer, you don't want to write SQL code, but you still want to get the benefits of a stream processing engine like RisingWave, you can get it now through the project called IBIS, Project IBIS. It's an open source project, and that way, that'll not only address most of the scenarios, I would say. Now if you want to write Scala code, then you're out of luck, but Python, I think that should address most of your use cases. I hope that answered the question.
Yeah, it looks like we have another other question
Okay.
by Julio.
Okay, let me push to the Q&A.
It says, what added value does StarRocks give if I can connect my BI tool directly to RisingWave? Or is it cross-streaming data with transactional data, for example, from a data lakehouse?
So you want to take it, Albert, or do you want me to?
Yeah. So I think so. This is a little bit of what Rayees was talking about, right? So the question is really around a temporal idea of the data itself. So if you want to listen off of the stream and create data or see, data in flight in stream, right? RisingWave can be a way for you to pull that data, right? But if you're looking at something where I need data that is maybe you can have seconds later, if not minutes, hours, days, weeks, months, years later, right? StarRocks being a traditional OLAP database, traditional data lakehouse, or can also be configured as a data lakehouse. We can provide those things, right? So it really becomes as a question about is how fresh of the data that you want to go and see, right? Obviously, just to even break that down a little bit more, they see inside of Kafka queues, right? What the data is moving across Kafka, right? We don't see it until it gets synced into StarRocks, right? And even inside of StarRocks, depending on what it is that from the ingestion time or whatnot, it may be a couple seconds before it actually shows up into a query or into a materialized view.
Yeah, I think there are two. You covered very well. The scenario where if you want to take a temperature of the data, like for example, if it's in Kafka, before ingesting, if you want to see trends or if you want to query right off of at an discrete event level, you could do that with RisingWave without persisting the data in RisingWave or when StarRocks, right? But there's also another scenario, what we call more data enrichment back to the original data source. Say if your data is coming from Kafka and some other CDC sources, and you have a pipeline built to do analytics in StarRocks, but the latency is too long, and you want an intermediate layer to do the transformations on the fly and then be able to quickly review those results without having to go to this thing. Well, eventually they will land in StarRocks, but in the intermediate, you want to do the same, whatever the upstream data source is, to do operational analytics. That use case is also possible with RisingWave because you're basically diverting whatever the CDC traffic or the Kafka traffic to do the transformations and basically and piping it back to the original data source. So there is different creative ways to get value out of stream processing. So the general comment I would make is it is not binary where it's not either or proposition between stream processing and batch. It's more a spectrum. If you obviously the use cases for stream processing are more on the real time and short latency side. So even if you have a batch use case and you feel like part of that needs to be moved closer to real time, you could employ a technology like RisingWave to do that. The shorter turnaround time for those kind of reporting or dashboards, while you can still see the longer term retention and the data for StarRocks.
I think that is all the questions that I see from chat. So with that said, Rayees, thank you for spending time out of your day today. Thank you, audience, for coming to our chat. Hopefully you learned something new in this space, right? Obviously, data is really, really big. Lots of new solutions, right? So thank you again for Rayees at RisingWave to come to one of our community calls.
Yeah, thank you, Albert and team, for inviting me. We have, like I said, deep integration with StarRocks, and we published a blog. I want to post the link to that blog for folks to learn more about a common use case and how we're, what engineering work we have done based on our customer engagement, actually. So I hope that's fun reading for you if you still want to learn more about RisingWave. And to learn more, go to risingwave.com. That's the place to get all the resources about RisingWave. Thank you.
Thanks.